Have you ever thought about how a machine could change the entire world? Not with computers or electricity, but with something as simple as boiling water? That's right, just water. Heat it up until it turns into steam. Today, we're going to fire up the boiler and break down exactly how this incredible invention really works.
I mean, it just sounds impossible, right? How can something as, soft and gentle as steam, the same stuff you make in your kitchen kettle, have enough raw power to move a 200-ton hunk of steel down a track? That's the big question here, and by the end of this, you're going to know the answer.
Okay, so every steam engine journey begins with its heart, the boiler. The easiest way to picture it, just imagine a giant, super strong metal kettle. You put water in, you crank up the fire underneath, and you start making steam. But this isn't your average everyday steam. And here's where the magic really happens. It's all about pressure. See, when you boil water in a totally sealed, incredibly strong container like a boiler, those little water molecules have absolutely nowhere to go. They start bouncing off the walls faster and harder. I mean, it's like they're at the wildest party you can imagine, just building up this immense, incredible pressure. So if you could listen to that high-pressure steam, it's basically screaming one thing. It's done being water. It is so done being calm, and it desperately wants out. This incredible desire to expand, that's the raw power source we're about to harness. It's just pure, contained energy waiting to be unleashed.
So we've built up all this crazy pressure. Now what do we do with it? Well, next up, we're going to see how all that energy gets turned into actual muscle. This is where the real engineering genius starts to shine, because we're about to put that pressure to work.
Okay, so if you could peek inside the engine, you'd find a hollow tube, a cylinder. And fitting inside it nice and snug is a piston. Just think of it like a big, solid metal plunger that's made to slide perfectly back and forth inside that cylinder. This simple little piece is about to become the engine's main muscle.
Now, here's the moment of action. We open a small valve just for a split second and let a blast of that high-pressure steam rush into the cylinder. Bam! All that pent-up energy expands in an instant, and it gives that piston one single, unbelievably powerful push, forcing it all the way to the other side. That one push, that's the birth of all the movement.
All right, so a single push in a straight line is great, but a locomotive's wheels need to turn in a circle, right? So the next big challenge for these inventors was figuring out how to convert that simple back-and-forth motion into continuous, powerful rotation.
Actually, before we get into the mechanics, think about something you definitely already know. Riding a bicycle. Your legs push up and down, right? But the wheels go round and round. A steam engine uses that exact same basic idea to turn a straight-line push into a spin.
The way it works is just brilliantly simple. The piston is connected to a long bar called a connecting rod. So when the piston shoots forward, it shoves that rod. The other end of the rod is attached to the wheel, but a little off-center, on something called a crank. It's just like a pedal on a bike. So that push forces the wheel to turn. It's simple, it's elegant, and it's incredibly powerful.
But hold on a second. For this to really work, the piston needs to push, then reset, then push again, over and over and over. How in the world does the engine manage that perfect timing? Well, for that, you need a component that acts like the engine's brain.
Meet the slide valve. This thing is an absolute work of genius. You can think of it as an air traffic controller, but for steam. Its one and only job is to slide back and forth with perfect timing, first letting the high-pressure steam into the cylinder to push the piston, and then opening up another little door to let the used low-pressure steam back out so the piston can return.
And that perfectly timed rhythmic action, steam in, steam out, that is what creates the iconic sound of a steam engine. That chuff, chuff, chuff you hear, it's not just random noise, it's literally the sound of the engine breathing. Each chuff is a puff of used steam being exhaled after it's done its job. So, we've got the heart, the muscle, and now the brain. Let's put all the pieces together and see the whole picture. Because once you understand this whole process, you can really start to grasp just how revolutionary this machine actually was.
Let's do a quick recap of the entire journey, from a drop of water to a moving train. Step 1. Water gets heated in the boiler. 2. The boiling creates that high-pressure steam. 3. Steam gets let into the cylinder. 4. That steam powerfully pushes the piston. 5. The piston moves the rod. 6. The rod turns the crank. 7. The crank spins the wheels. And step 8. The train moves forward. It's this beautiful chain reaction, all powered by nothing more than fire and water.
So why does any of this matter? I mean, really, what's the big deal? Well, before this machine, the absolute fastest anything could travel over land was the speed of a horse. For thousands of years, that was the limit. Then, all of a sudden, steam power let us move massive amounts of goods and people across entire countries, not in months, but in days. The world literally shrank. This single invention fueled the Industrial Revolution and connected humanity in a way that was completely unimaginable before. So in the end, you see, the steam engine was so much more than just a clever machine. It was an engine for progress itself. It didn't just move locomotives from one station to the next. It fundamentally moved all of humanity forward into the modern age we live in now. And to think, it all started with the simple power of boiling water.